Hello guys, today we are going to talk about the definition of time. So in the previous video we have talked how we achieve the definition of meter, but today we are going to talk about time. What is time and how it was achieved. So from previous video we know one thing, that at first pendulum was used to measure 1 second, right? So in 1583 Galileo observed that for a particular pendulum having a constant length, always has a constant oscillation. So what it means, that time taken for a particular pendulum having a constant length to move from initial position to position A, then from A to position B, then from B to again to initial position, total time taken is always constant. It means that time taken for a particular pendulum having a constant length, time taken for a single oscillation for a particular pendulum having a constant length is always constant. So at first it was tried to make this constant time period 1 second, right? But we know that after that time period, formula of time period was formulated as 2 pi root over L by G, and it was seen that the value of G is not constant. It changes due to the change in the height of terrain, meaning if G is measured on a plane, it will be different than the G measured on a mountain. So obviously if G is taken as a parameter to measure time period, and if time period is taken as a parameter to measure 1 second, then the value of 1 second for the people living on a plain area will be different from the people living on the mountains. So it will be very problematic, it will be unscientific. So this theory proved to be useless. So the scientists and physicists tried to figure out another way to measure time. Experimentations were going after this, but breakthrough happened in 1964 when 1 second was measured with an atomic standard. What is measuring time with respect to atomic standard clock? We use an atomic clock. Okay, we use cesium 133 in that atomic clock. So what does that atomic clock do? So that atomic clock measures the periodic vibrations of a cesium 133 to measure 1 second. Now what is the meaning of this? Measures the periodic vibration of a cesium-133 to measure 1 second. Actually it is seen that to excite a cesium-133 atom from its ground state to excited state to higher state takes a constant amount of microwave vibration, right? So we are talking about that vibration. So if each and every time the number of vibration is the same to excite a cesium-133 from its ground state to higher state, that constant vibration can also be used to measure a constant time period. So that was used to measure 1 second. How it was done, I will show you. So what we do is, in a chamber cesium-133 gas is heated. Why heated? After heating, some of the cesium gas will absorb the heat and get excited and will produce cesium ion, but not all of the atom or all of the cesium-133 atoms will get excited, right? That is the rule. Not all of them gets excited because it is not possible for all of the atom to achieve that energy. So after being heated, that excited gas jet is released from this chamber. So this is what? This is a mixture of cesium-133 gas with some excited and some are not excited. Some of the cesium-133 atoms gets excited and produce what? Ion, cesium-133 ion, and some are yet to be excited, right? So those which are not excited will be used in the later portions. How? The cesium ions show magnetic property. So we have to separate these cesium ions from those cesium-133 atoms which are not excited. For that we use a magnet here. So when this jet goes through this magnet, excited cesium atoms gets attracted towards the magnet and non-excited cesium atoms move straight. These are non-excited and these are excited. So using this magnet we separated the excited and the non-excited cesium atoms. So these non-excited cesiums are passed through a resonator. These non-excited cesium atoms are passed through a resonator. What does a resonator do? In resonator, the microwaves I was talking about, those microwaves that excites the cesium-133, in resonator that microwave is produced. So how it is produced? A quartz crystal produces the microwaves. So a quartz crystal produces microwaves and these waves flow through this resonator over these non-excited cesium atoms, right? What is this? This will become relevant now when this resonator produces microwave radiations. It is seen that each time when this much microwave vibration happens, 9192631770 number of microwave vibrations, after this exact number of vibration, all of the cesium atoms gets excited from lower state to higher state. Each and every time it is measured, each and every time the number is still the same. So it is seen by the scientists, it is observed by the scientists and the physicists that in each time we do the experiment, the number of microwave vibrations is 9192631770 times. After this much vibration, all of the cesium 133 atoms goes excited from lower state to higher state. So we have a constant time period to excite the cesium. So how this time period will be used to measure 1 second? We have to detect it, right? So we have to measure the time span, we have to measure the time it takes for this number of vibration. So we will measure the time span when the non-excited cesium 133 are moving inside the resonator and the excited cesium 133 is getting out of the resonator, the time between those two, the time span. So it means the time taken, the number of vibration, it means the time taken to complete this number of vibration to excite a cesium 133 atom from its lower state to higher state, right? So whenever these cesium atoms, these excited atoms are now passed through a detector, we use a sensor here, right, on the detector, so it can detect the change in energy level. So whenever it detects the change in energy level, it produces an electrical pulse, So when at first lower state cesiums are entering this detector, it will not detect higher energy, so it will not generate any electrical pulse. Whenever this much microwave vibration is reached, at that exact time all the cesium 133 will be of higher state. At that time, at that right moment, the detector will detect the change in energy state and it will produce a electrical pulse. So we have achieved the time span between lower state and higher state. So this electrical pulse will produce a one tick, means 1 second, right? So this is how one electrical pulse used in this atomic clock generates 1 second. So what will be the definition? We know that it takes 9192631770 number of vibrations to excite the cesium-133 atom from lower state to higher energy state. Right? So the definition would be the number of vibration it takes, the number of vibrations it takes to excite cesium-133 atom from lower state to higher state is 1 second. The number of vibration it takes to excite cesium-133 atom from lower state to higher state is 1 second. So we have success now. This is the measurement of 1 second we use now. Now similarly, scientists and physicists thought that we have the measurement, we have the exact measurement, and this system will be taken, but this definition can prove to be very difficult for students who are just starting to learn the basics of physical science, physics. So for them a very simple formula is needed. For that, what we used? We used the measurement of 1 second and used another universal parameter to produce a very simple definition. What we used? We use for the student 1 solar day. 1 solar day means we all know time taken for one single day, right? So what it is? 24 hours. 1 solar day means 24 hours. So we converted this 24 hours into second. So 24 hours is 24 into 60 into 60 second, right? So it is 86,400 second. So we know that 86,400 second is 1 solar day, right? It's very easy. For students this is used. So 1 second is 1 by 86,400 solar day. So now the simpler definition for student who just started learning the basics of physics is that the time taken to complete one by 86,400 part of a single solar day is 1 second. So just imagine, from that measurement of time using one atomic clock, we have achieved a more simpler definition, right? So this is how we measure second now. The measurement is done by atomic clock, right? That measurement is used and converted to a more generalized and simpler form using one solar day, because it is universal, it will always be constant, that's why. So this is for today. Thank you guys. See you in the next video.